welcome back to another video. In this video, we'll be discussing another group of organic compounds, which is carboxylic acids, which is a quite new topic. Maybe for the first time, you guys are gonna even hear about this word carboxylic. So it's a group of another group of organic compounds. So it has a couple of reactions and stuff like that that we need to know according to your syllabus, and we will cover all that during this in this video. All right. So what we learn about is what are carboxylic acids, and then we learn about the chemical and the physical properties of carboxylic acids. All right. There. So as I said earlier, they are organic compounds which have so basically an organic compound will definitely have a carbon-carbon bond. That's a must. And the carbon-carbon bond in carboxylic acids are single bonds. All right, so you can see in this diagram, so all are single bonds. Okay, but what makes this unique, what makes this special from other organic compounds is this particular bond, COOH bond. And the most important thing about this bond is there's a pattern in which this bond takes place. The pattern is one of the oxygen forms a double bond with the carbon. All right. So out of the two carbons, out of the two oxygens, one oxygen forms a double bond with carbon. So you can see in this diagram, see, one oxygen forms a double bond with carbon. See, and then the other one is just a OH bond. All right. So be mindful of this. And then if you notice if you notice in your textbook and stuff, in your textbook, the names of carboxylic acids normally end with a suffix like with noic. Okay, so if there is a carboxylic acid with two carbons, it will be called as a ethanoic acid. If there are three carbons, it will be called as propanoic acid, and so on. Okay, so this is a general formula. Like, as you know, for each and every group of organic compound, there's a particular general formula. So carboxylic is no different from that. It also has a general formula. So this is a general formula. So my advice is do not you can see that that here we have distinction shown the COOH bond, right? So keep it this way. Remember this particular general formula in this way, which is very easy for you all also to identify and eliminate any mistakes that you would do in your examinations. Like what I mean is, do not add this carbon into this and then form a different general formula. Stick with this more nicer and more and the tendency of doing mistakes is reduced definitely. Okay, so with that in mind, that's the basic description about it. This is a very important feature. Okay, so now when we see this carboxylic acids, okay, it mentions the word acid. So basically you would know right now that we are talking about some organic acid that we are talking about, right? So this acid, now acids in chemistry have there are two kinds of acids, right? There are strong acids and there are weak acids. So until now, what you have learned, all of this HCl, sulfuric acid, nitric acid, they are all strong acids. Okay. Now carboxylic acids are weak acids. Okay. Now there's a difference. There's a way that we are able to distinguish strong and weak acids. What's that factor? The factor is that weak acids do not dissociate in water completely. Okay. So dissociate is a big word. So in simple words, if we say weak acids do not react with water completely, whereas strong acid will react with water completely. Simple as that. Okay, so this is a statement. So if someone asks you what's the definition of a weak acid, the definition of weak acid is they do not dissociate in water completely. Remember this word. It's a nice word that you could use to describe weak acids. And then you have this particular, if you want to actually validate what we are saying, whether this because in chemistry we always involve ourselves with chemical reactions. We can prove this also using a chemical reaction. So basically, we are reacting an carboxylic acid. In this case, we are reacting ethanoic acid with water, and then you can see that like a normal acid, it dissociates into ions, its respective positive and negative ions. But the unique feature in this is, if you can see that there are two arrows, each one pointing to the opposite directions. Okay, so this what it means here is what we want to tell is that, for example, if you take this in terms of atoms, okay, say that there are 100 atoms of ethanoic acid. Okay, there are 100 atoms of ethanoic acid and you're reacting it with water. Out of the 100, not all the 100 atoms will react with water to form these ions. It could be 50 atoms, it could be 75. However, there is a proportion that does not react with this water. Okay, so that's what we want to say from this uh, double arrows, two arrows pointing to the opposite directions. So there is a portion that will not react with this with the water. All right. So in certain textbooks they would be these arrows would be indicated as half arrows pointed towards the opposite direction. But also if you indicate them with full arrows pointing towards the opposite direction, it won't be wrong. All right. Then if you do a practical with this, if you react ethanoic acid, and you would see that the rate at which hydrogen gas is produced, hydrogen bubbles are produced, is very slow when compared to strong acids. If you react to strong acid, you will see the rate at which a hydrogen is produced is really high. All right. And then if you measure the pH using a pH probe, you will see weak acids will vary from a range from of 3 to 6. All right. Yeah. So that's the whole point of these weak acids, because you will definitely be asked questions with regard to carboxylic acids. So there will be a mixture of carboxylic acids, and then they'll be also asking about weak acids. All right. Then we come to the reactions. So when we talk about reactions, basically we are talking about the chemical properties of uh, any substance. So in this case, we are talking about chemical properties of carboxylic acids, and there are basically a few reactions that we have to look into. Okay, the first one is the reduction reaction. Okay, so what is a reduction reaction? So basically, we want to reduce this carboxylic acid into another compound. Okay, so how are we able to achieve it? That is the whole point of. So similarly, in the previous video, I mentioned about something called a oxidizing agent. Okay, so similarly here in chemistry, we have something called a reducing agent. So this reducing agent is nothing other than this whole big complex compound. Okay, so remember this compound. Okay, remember this. So this is a reducing agent that will reduce this carboxylic acid into its corresponding uh, alcohol. So, for example, ethanoic acid, if you react it with this lithium aluminum hydride, okay, the name of this is lithium aluminum hydride. If you react with this, we are able to get ethanol. If you react propanoic acid with lithium aluminum hydride, you are able to get propanol. So that's the way you are able to. So basically, it's a reducing it. It will reduce carboxylic acid into an alcohol. Okay, remember these conditions. These ether and water are conditions. Okay, this is the reducing agent. These are the conditions. Ether and water are the conditions in which we have to react this or do this reaction in order to obtain a desired product. All right. Then there are now the other reaction that we will look into is now basically despite carboxylic acids being weak acids, okay, they are however acids, right? So all the reactions that you knew about acids prior to this carboxylic acid, they all apply to this carboxylic acids also. Okay, so for example, the way normal strong acids reacted with metals, metal oxides, metal hydroxide, metal carbonates, the similar pattern, they will react with these carboxylic acids. Okay, so for example, I've given you two examples. I've given you the example with metals and metal carbonates. So if you react ethanoic acid with a metal, which is zinc in this case, you are able to get a salt and hydrogen gas. All right. And in this case, we have reacted ethanoic acid with calcium carbonate, which is also calcium carbonate is an example for a base. Okay, so basically we are reacting an acid with a base, and we are able to get our desired products, which is a salt, water, and carbon dioxide. Okay, so this is a example for a what? It is example for a neutralization reaction. Okay, so these are the reactions that you can see they are similar. So if you had reacted an HCl with zinc, you would be able to get a salt and hydrogen. If you reacted HCl with calcium carbonate, you are also able to get a salt, carbon dioxide, and water. Okay, so no difference in those reactions. Okay, so I've done for metal and metal carbonate. So as a practice, you could do reactions with metal oxides and metal hydroxides. And if you want to check your answers, you could definitely forward it to me through WhatsApp, and then I'll see whether, if you have any doubts, definitely you can definitely do them and forward to me through WhatsApp if you want to see whether any corrections need to be done. All right. The third reaction that we look into is esterification. Okay, this is a reaction where carboxylic acids react with alcohol under certain conditions to produce an organic compound called esters, which will be our next topic. So esters is another group of organic compound that we will be learning in the next video. So just keep in mind for the time being that carboxylic acids will react with alcohol under certain conditions to give esters. So we learn esters and esterification. So the process in which we are able to form esters is called esterification. Okay. So esterification we will learn in detail when we do the esters lesson. Okay, so for the time being, you be very familiar with these reactions. Okay, now when we talk about these chemical properties, I would want to also mention this part also. Now, in our previous uh, organic compound groups, for example, alkanes, alkenes, and also alcohols, uh, those organic compounds exist in nature as they are. So basically, alcohols you can find, alkenes you can find, alkanes you can, but carboxylic acids do not exist on their own. Do not exist on their own. Okay, so the way we are able to obtain carboxylic acids, for example, ethanoic acid, maybe propanonic acid, the way we are able to obtain is basically we have to oxidize an alcohol to obtain the desired carboxylic acid. Okay, so I discussed this in the previous video, but I just wanted to emphasize on it once again. So you have to just simply oxidize, say an alcohol, say you're oxidizing propanol, you're able to get propanoic acid. If you want to oxidize ethanol, then you're able to get ethanoic acid. Okay, so there's the way that carboxylic acids are formed. Okay, so be mindful of that also. And yeah, and let's move on to the last slide, I guess. Yes, so we'll discuss about the physical properties of carboxylic acid. Physical properties are mostly similar to the ones like the other organic compounds. Boiling points and melting points increase as the carbon number increases. Density increases as the carbon number increases. And also, a very important point is we want to mention here is the solubility of this organic compound. They are extremely soluble in organic solvents. All right, and similar to alcohols and other substances, they are colorless and odorless. So you cannot detect a carboxylic acid through your senses. You can't smell them, nor can you see them. Okay. So how are we able to distinguish a carboxylic acid? That I will teach you in the next uh, video more specifically. But also, if you watch my video on alcohols, you know how we are able to uh, uh, identify carboxylic acids. All right. So this is it for carboxylic acids. Okay. So there are few things that you need to know about. You need to know the general formula of carboxylic acids, then the description of a weak acid, and stuff like that. Then the chemical reaction that you need to be familiar with, and also be familiar with the physical properties. So it's not a very big chapter, but definitely when you go to your higher grades, definitely there will be plenty reactions that you will learn associated with carboxylic acids. But for your knowledge, this is the limit that we need to be doing for your examinations. Okay. So yeah, so that's it for this video. I'll meet you in the next video. So thank you for attending this. Thank you.